Hi everyone, this is Meganadh. In this video, we're going to learn about operators in C#. So let's see the agenda for today's video. So first we will start with operators in C# and what are the different types of operators like arithmetic operators, logical operators, relational operators. So we'll learn about all those operators in this video, and also we'll learn about what is the topic that we are going to discuss in the next lecture. And at the end we'll have quiz on operators that we are going to learn in this video. Okay, so let's get started. So there are different types of operators, and these are arithmetic operators, relational operators, logical operators, bitwise operators, shift operators, unary operators, and assignment operators. So almost all these operators are common in all programming languages, not only in C#. You find these operators in C language, C++, C#, Java. Almost all programming languages will have. These operators will play a critical role in writing business logic. Let's take for example, I want to check whether the year is a leap year or not. So we have to use modulo division for that. And if I want to do some multiplication, we'll be using multiplication fact, this one for multiplication. And this is for assignment. If you want to assign some value for a variable, we use equal to. And this is for logical operators like AND condition, OR condition, and NOT condition. So we are going to see one by one with some examples, and we'll understand more in detail. So let's get started. First one, arithmetic operators. So I don't think we need explanation for this. So plus sign is used for addition, and this is called an operator, and this is called operand, and this is also an operand. So 6 plus 3 is 9, 6 minus 3 is 3, 6 multiplication. So for multiplication we use this symbol asterisk. So 6 star 3 is equal to 18, and this is normal division. 6 by 3 is equal to 2, and this is called modulo division. So remember, modulo division will give the remainder. So we'll see about that in the next slide. So I'm going to focus on these two things because these are the ones which normally developers get confused when they start their career. Okay, so let's see them now. So normal division is 5 divided by 2 is 2.5, and 12 divided by 2 is 6, 0 divided by 4 is 0, and this is straightforward. And now let's see what is modulo division. So modulo division will return the remainder. So let's say this 12 modulo 5. So first what you have to do is write this 5 here, and the second one here 12, and then 5 2s are 10, and remainder is 2, and that is the answer. So modulo division will give the remainder. Let's take for example, I'm going to do 16. I'm going to do 16 modulo 5. So what I have to do here, I have to write 5 here, and I have to divide 16 with 5. So 5 3s are 15, and the remainder is 1. So this is the answer, the value for 16 modulo 5. Now let's see one more thing. So what is the answer for 22 modulo 8? So what is the answer? So first you have to divide 22, and I'm going to write here. So 8 2s are 16, 8 2s are 16, and the remainder is 6. So this is the answer for 22 modulo 8. So keep in mind, modulo division will return the remainder. And what if this number is smaller than this number? In that case, what will happen? We are going to see in the next slide. So 11 modulo 12. So in this case, what you have to do is you have to write like this 12, and this number always you have to write here, and 11, and you will be writing. So 12 once, 12 it will not even go once. So let's put 12 zeros are 0, and the remainder is 1. So that is the answer for 11 modulo 12. So remember, when numerator, this is called numerator, and this is called denominator. When numerator is smaller than denominator, the answer will be numerator itself. I repeat, when numerator is smaller than denominator, the answer for modulo division will be numerator itself. So let's see that now. See here, 12 zeros is 0, and remainder's answer is this one. So that's the point which I said now. Numerator is smaller than denominator, modulo division will return numerator itself. Okay, you need not put pen and paper as well. So don't get confused between 12 modulo 11 and 11 modulo 12. So 12 modulo 11, the answer is 1. So 12 modulo 11, the answer is 1, and 11 modulo 12, the answer is 11. Okay, so most of the times I see students gets confused between modular division. So just keep in mind, when the first value is smaller, blindly put the answer as first value itself. Okay, so let's see the next one. Now we are going to discuss on relational operators. As the name of the operator itself suggests, that it's going to check the relation between two operands. So for checking equality, we use double equal to. Okay, so single equal to is used for assigning. So if you put a is equal to 5, so that means I'm going to assign value 5 to a. So single equal to is used for assigning. For checking condition, we use double equal to. So double equal to is used in, mostly we use an if condition to check whether these two numbers are equal or not. So this is not equal to, this is logical not, and we are using not equal to, and 5 not equal to 3, and this greater than, 5 greater than 3, less than, 3 less than 5, greater than or equal to, 5 greater than or equal to 5. This is true, because greater than or equal to, anyone succeeds, that will be true. Less than or equal to, so 9 less than or equal to 12, that is true. Okay, so one point to note down here is, for checking equality in if condition, we use double equal to. Okay, so keep in mind, we're going to do some programs where we use this. Now let's go to the next one. Logical operators. So logical operators we use extensively in programming because our business logic will depend on multiple conditions. Okay, so let's take a simple example. For if you are designing an e-commerce website, and if you are to put, like, say for example, if it's electronic item and if it buys 2 quantity, you're going to give 20% discount. If it's apparel and if it buys 5 quantity, you're going to give 60% discount. So you have to put logical condition there. If this product is this and this quantity, so in that case you have to use, for writing business logic in such scenarios, we will be using logical operators. Okay, so see here, AND operator means both should be true. AND operator means both should be true. OR operator means if any one is true, even then the result will be true. Okay, and this is not logical not. We saw that before in the before slide as well. This is not. Okay, so let's see, this is called truth table. So AND becomes true only when both are true. True and true is true. In all other cases it's false. And OR condition will be true if any one of them, minimum any one of them should be true. See here, both are true, OR is true, true false, true, false true, true, and both are false, that is false. So this is called logical operator. And logical AND we use 2 ampersand symbol. Logical OR we use this called pipe symbol, 2 pipe symbols, and this is for logical NOT. So we'll see some programs in the next lecture, where we start with Visual Studio. We're going to see some programs for all these operators. Okay, now let's go to the next one. Bitwise operators. Although we don't use these in exhaustively in our day-to-day programming, but still for embedded based programming we need to know about this bitwise operators as well. So I'm not going to discuss much details on these bitwise operators. Let me quickly show you how you will arrive at the result. Let's take for example bitwise AND. So don't get confused between bitwise and logical AND. So bitwise AND will have 1 ampersand symbol and logical AND will have 2 ampersand symbols. Okay, so bitwise AND, let's take for example 6 and 3. What you have to do is 6 convert it to binary, so that's 110, and 3 convert it to binary, that's 001. Now what you have to do is, so 0 means true, 0 is false, 1 is true, true true, false true. So AND operator means both should be true. So in this case 1 and 0 is 0, 1 and 1 is 1, 0 and 1 is 0. So and the result you have to convert it to binary decimal. That is the answer. Okay, similarly for OR operator, 1 or 0 is 1, 1 or 1 is 1, 0 or 1 is 1. So when you convert this to decimal, you're getting the answer as 7. Now last thing is XOR. XOR is nothing but exclusive OR. Exclusive OR nothing but one should be true and one should be false. That is called exclusive OR. So only then the result will be true. So true or false, true XOR false, true, true XOR true, this false. Exclusive OR indicates that one must be false, one must be true. So in this case, when you convert this to 2 power 0 and 2 power 1 and 2 square, so this is actually this is 5 here, there is a small typo, this is 5. Okay, So now let's try to understand more about this bitwise operator one more time. Okay, now I'm going to explain you here. Now let's take, for example, I want to find 5 and 2. Okay, so what I have to do here, 5 I have to convert it to binary, which is 101, and 2 I have to convert it to binary, and which is 0 1 0. So 2 power 0 and not 0. So let's see once again. So 5 I'm going to do and 2. 5 is 101, and how about 2? 2 is 1 0 0. So 2 power 0, 2 power 1. So this is, now if you want to find this, see here, I want to find AND, logical AND. So logical AND means both should be true, so it will be 0 0 0. 1 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, so answer is 0. So 5 and 2, the answer is 0. And let's see what is 5 OR. So OR means 1 or 0 is 1, 1 0 or 1 is 0. So all ones will be there, and when you convert this, that will be 7. That will be 7. And we can actually see that. Let's verify this in calculator. So what is that values we got? 5 and 2 we got 0, 5 or 2 we got 7. Let me open calculator now. We'll quickly verify them using calculator. So I just open calculator, and I'm going to put here as decimal, and I'm going to put here 5 and 2. So we got 0. 5 and 2 we got 0, and 5 or 2 we got 7. So let's verify that 5 or 2. So I'm going to put 5 or 2, and let me put equal to. So we are getting 7. So whatever we did is correct. So that's how we do convert. We will have bitwise operators. So although we don't use them we don't use them much, but still we need to know them. Okay, so let's go to the next one, shift operators. So bitwise and shift operators, we don't use them more frequently in our day-to-day programming, and let's try to understand. This is called left shift operator, and this is called right shift operator. This is called, the first one is called left shift operator, and the second one is called right shift operator. Now let's see this. So first what you have to do is convert this 6 to binary. So that will be this 110. Now left shift operator means, left shift 2 means you have to move this left side 2 times and add zeros at the right side. So 0 and 0 here. Now convert the whole thing to decimal, and that is our answer. Okay, and coming to, I will explain this with one more example. And coming to right shift operator, so put these numbers like this. Let's assume that there is a hill here, and when you push these items to right side, 2 items will fall down and only 1 will remain here, and when you convert this to decimal, you'll get 1. So to explain this more clearly, I'm going to open MS Paint and show you about left shift and right shift operator. Let's see this now. I'm going to take this, and okay, so I'm going to show you 7 right shift 2, 7 right shift 2, and 7 left shift 2. Let's see this now. 7, when you convert to binary, the answer is 1 1 1. So now right shift 2 means you have to push this right side to, let's assume there is a hill here, and these two things will fall, these two things will go off, and only 1 will remain. So when you convert this one to decimal, so 2 power 0 into 1, that will be 1. So 7 right shift 2, the answer is 1. Now let's see what is the value for 7 left shift 2. So when you convert 7 to binary, the answer is 1 1 1, and when you do left shift, move this left side 2, you have to add 2 zeros here, and then now you have to convert this to binary. So 2 power 0 and 2 power 1 and 2 square and 2 cube and 2 power 4. So what is the answer now? 16 plus 8 plus 4 plus 0. So the answer is 28. So 28 is the answer for 7 left shift 2. Okay, so very simple. Right shift, remove those number of elements. Left shift, put this left side and put zeros and convert that to decimal. That is how, that is what is called right shift and left shift operators. Now let's go to the next one. Okay, now this is the one which is most frequently used among all operators, in almost every for loop we use this. In writing so much business logic we use this. This is called unary operators. Okay, so we have two things, plus plus and minus minus, and here you can see that this way of writing is called post increment, and this way is called pre increment, and this is post decrement, and this is called pre decrement. So this is very simple to understand. Let me explain you one. So first thing, now I have this a is equal to b plus plus. So this is called post increment. First the value of b will be assigned to a, and then b value will get incremented, and then b value will get incremented. So now let's see an example. Let me show you one more time. So I'm going to open Notepad, and I'm just going to open Notepad and format font. I'm going to show you now. Let's say this now. I'm writing a is equal to 5 and b is equal to 10. Now a is equal to b plus plus. Now console.writeLine a and console.writeLine. So let's put like console.writeLine b. So this is the most frequently asked question, like based on that operator. So let's see now. I'm going to explain this now very clearly. First thing, a is equal to 5, b is equal to 10. So a is equal to b plus plus. This is called post increment. This is called post increment. First the value of b will be assigned to a. First the value of b will be assigned to a, then the value of b will be incremented. Then the value of b will be incremented. So answer for this is value of b will be assigned to a first. So here value of a will be 10, because first this value will get assigned, then b value will get incremented. So in this case b value will become 11. This is the value of, this is the output for this program. So let me explain once again now. I'm going to put here, let's put like I'm going to put here b is equal to, a is equal to 1 and b is equal to 3. I'm going to put here 2. Okay, now I'm putting again, it is a is equal to b plus plus. So first value of b will be assigned to a. So a value will be 3, and then b value will get incremented. So b value will be 4. So plus plus means that will increment the value by 1. Okay, so now let's see this now. This is called post increment. So this is called post increment. First it's assigning, then it's incrementing. Okay, now similarly we have pre increment. So plus plus b. So in this case what happens is, first the value of b will be incremented, and then the resultant value will be assigned to a. So in this case what happens now is, first the value of b will get incremented by 1, so b value will become 4, and then that value will be assigned to a. So a value will be 4, b value will also be 4. So that is called pre-increment. Remember, in case of pre-increment or pre-decrement, both will be equal almost. Every time both will be equal. Let's see now, what is this b minus minus? So this is called post-decrement. This is called post-decrement. So here what happens is, first the value of b will be assigned to a, and then b value will get reduced. B value will get reduced. So a value, b will be assigned to a, so it will be 3, and b minus minus, so it will be 2. Okay, now the last one is minus minus b, and this is again straightforward. This is actually pre-decrement, and here a value and b value both will be same, and that will be 2, 2. First the value of b will be reduced, and so 3 will become 2, and then this will be assigned to a, so both will be 2 here. Okay, so this is about unary operators. So we have post increment, pre-increment, post decrement, and pre-decrement. Hope it's very clear now. Let's see this now. So let's see now some demos. One more example now I'm going to show you on unary operators to make things very clear for you. Let's see this now. I'm going to open Notepad one more time, and let's see this now. Let's analyze now. P int p comma q. Okay, so p is equal to 5, p is equal to 6, q is equal to p plus plus. Now I'm going to put P here, I'm going to put Q here. So this operator is called post increment. This operator is called post increment. So first value of P will be assigned to Q. So Q value will be 6. And then P value will get incremented. So P value will be 7. Now let's see P minus minus. This is called post decrement. So first the value of P will be assigned to Q and P value will get reduced. So here Q value will be 6, P value will be 5. Okay, now let's see this minus plus plus P. So in this case, this is called pre-increment. First the value of P will be incremented and then this value will be assigned to Q. So both values will be 7. And last one is called pre-decrement. First the value of P will be decremented and then this will be assigned to Q. So in this case, both will be 5. So we are clear with unary operators. We are clear with these 4: post increment, pre-increment, post decrement, and pre-decrement. Okay, so let's see what's next for us. So the next one is assignment operators. So as we discussed in the first slide, equal to is used for assigning. So let's take, I'm writing A is equal to 10. So value of 10 will be assigned to A. And if I'm writing B is equal to 20, value 20 will be assigned to B. So this is called assignment operator. Okay, now so there is something called A plus is equal to B. This is one thing that we have to remember now. Let's try to understand this. So when you write A plus is equal to B, that is equal to A is equal to A plus B. So that is the shortcut for this. A is equal to A plus B is exactly same as A plus is equal to B. Increment A by value that of B value. So that's what is called increment A value with B value. So A plus is equal to B is same as A is equal to A plus B. Similarly, A star is equal to B is same as A is equal to A star B. A is equal to A star B. So just keep this in mind. So A plus is equal to B is A equal to A plus B. A star is equal to B is A equal to A star B. And similarly with other operators as well. Okay, so this is about assignment operators. So just to summarize, we learned about all operators. We started with arithmetic operators, then we learned about logical, relational operators, and then bitwise operators, shift operators, unary operators, and assignment operators. Okay, so in the next lecture, lecture 4, we are going to learn about Visual Studio Editor and the first C# program in Visual Studio. So already we learned about how to compile in command prompt the first C# program, and now we are going to see how we can do it using Visual Studio. So I'm sure everyone would have installed by this time Visual Studio by watching the video which is there in installation playlist of my YouTube channel. Okay, so let's go to the next one. So now it's the time for you to take the quiz, which is described in for which the link is present in the YouTube description for this video which you're watching now. So please take the quiz now. Don't forget to subscribe for more videos. Okay, that's all from my side for this lecture. Thank you. Keep learning and keep practicing.